this in your notes, but when you're working with the Pythagorean theorem, you always are dealing with legs and a hypotenuse. When you're dealing with a right triangle, what segment will always be playing the role of a hypotenuse? Which one? The long one, the one across from the 90, correct. So the one that is always across from the 90 or opposite the 90 is always going to be considered our hypotenuse. The reason that it's the longest side length is because, well, what's the largest angle in a right triangle? 90. Can I have any other angles larger than 90 in a right triangle? No. That's why that works. So the other two you just call legs, and like I said, I know you guys have all seen this before, it's nothing too crazy. These are two legs. This was your A, your B, and your C. So the other thing I wanted to show you real quick was that you guys have actually been using Pythagorean theorem a lot longer than you actually even think. For example, remember when we did distance formula? If I want to find the distance between 2 points, remember the way that we did it? We just counted. Remember this? 1 little, 2 little, 3 little spots, 4 little, 5. Remember doing that? No. All right, well, let's count this. We're fun. Let's sing. Come on. I had a bad weekend. You can help me feel better. I'm going to pull that card. Come on. Is it going to kill me? Why not? My cousins lost their dog too. Not like lost, but dead wise. I'm sorry. So what we did is we, instead of using the long drawn out formula for distance formula, change in x quantity squared, change in y quantity squared, square root of y, you count. You went up 5, you went over 4. Ladies and gentlemen. And then from that, it made a right triangle, and then we just used Pythagorean theorem. I know that we weren't technically using Pythagorean theorem because we hadn't technically introduced it yet, but it's something that all of you guys have seen. So where we're going with this, though, is that one of the things I want you guys to see is on that, for example, on that one worksheet you guys had, there was one of them that you didn't have to do, but I want to start with number 11. came up second R. I will always provide to you the different formulas for areas. I'm not going to make you have to memorize any of those. So even if you couldn't remember what some of them were, I think Mrs. Thrower had written some of them on the board for us. Since there are a few that were there from second hour, there were still some area formulas up here, right? You guys got class? They erased them? Oh. Yeah. Right. If you only had this thing on your computer called Google that you can look something up, that was sarcasm. So here, in order to figure out what the area is, you have to do that. It's a triangle, so you have the 1/2 base times height. Now, this means it's what kind of a triangle? It's isosceles, very good. What did the altitude do to the base of an isosceles triangle? Bisects it, good. So this gives you 4 here and 4 here, which means the whole thing is then 8. Okay. Now, the heights then of triangles are where the right angles are created. So that means I have to do an extra step here to figure out what is this missing value here. So if you think about it, is this missing value here a leg or is it a hypotenuse? It's a leg. So what we have to do is 4 squared plus something squared is 12 squared. Okay. And just start pressing some buttons. We get x squared plus 16 is 144. Subtract your 16. Excuse me. 128, I believe. Now, this is where that multi-view calculator is going to be worth every single penny. It leaves it in simplified radical form. I know the instructions here said round to the nearest tenth. Whenever we're doing right triangle stuff, the only time when we use rounding is when we're doing trig functions, and that's the only time when we're worried about decimals. So here, it's going to be simplified radical form. When I do that, you get, what is that, 8 root 2, I believe? We just have it with that, that's why. And that gives me my overall length. Okay. Yes, ma'am. You can leave it like that, because your calculator will leave it like that. And the main, like I keep saying, is the main reason that we're going to keep these radicals in it isn't so much for what we're doing today. It's for when we get to, can you see the green okay? It's for when we get to what are called 30, 60, and 90 right triangles, because they're going to have ratios of sides that have square roots in them. And depending upon what values you know, this needs to be multiplied or divided. And that calculator does it automatically. And it's cleaner and less cumbersome than having to do decimals. So that's why we keep pushing that one. So that gives us our height then. So we have 1/2. Base is the whole thing. Height is 8 root 2. When you put all that together in that calculator, it gives you an exact answer. And it should be 32 root 2, I believe. Something squared. And that would be your answer. If you hit the double, you know how to get the decimal out of that from those calculators? The double arrow, very good. Hit that double arrow and go from there. Okay? Is that clear up on that one? What else am I looking at? Yes, ma'am. The area would be the whole thing. And what I did here is, notice I used this is the whole base, and this is the whole height. Now, if you did this, if you found the 1/2 of 4 by 8 by 2, 8 root 2, and then doubled it, you would get the same. Because then you would get, well, what's half of 4? What's 2 times 8? What's 16 root 2 plus 16 root 2? So it works either way. It works either way. With a lot of these shapes, you can do composites. What I mean by composite, you can do more than you can do 2 areas at the same time. What else you got? Yes, sir. This is is one you would have to do the composite out of it. But it's fairly simple. Because if you look at it, isn't this a rectangle and a triangle put together? So the area of a rectangle is a base times height. Area of the triangle is 1/2 base times height. So by redrawing that vertical line there, that rectangle off to the left, bring that down. That means this side has to be 4, this side has to be 3. Well, if this much is 3, how much is this? 10. And then you piecemeal it together. You have a 3/4, bless you, plus a 1/2, 10/4. So that's 12, 20. You get 32 square inches. Good times. I do want to show you how to set up something like number 35. Remember how the other day we had a quadratic problem? We had to do the squares, foiling, factoring, that whole thing. It does show up from time to time. Like I said earlier, it's one of those things that's reoccurring throughout geometry. But they're going to give you some information on how to set it up. Now, in order to set this up, you just have to read it carefully. They tell you the distance from A to B to C and back, so the perimeter of this was 1,400. Okay. It tells you that the hypotenuse is 600. So if the whole thing was 1,400 and you take out 600, how much is left for the other two sides? 800. Good. So that means from B to C and C to A, it's going to have to equal 800. I don't know what either one of them measures, but I know that would have to be the case. So since we're going to use Pythagorean theorem, if I just call one of these values x, what would the other one have to be in terms of x? Nope. No, remember the whole thing when I always say from here to the door is 10 feet? I go 3 feet, how much is left? 7, what'd you do? Okay? From here to the door is 10 feet, I go X amount of feet, how much is left? 10 minus X, very good. Isn't that the same thing, just bigger numbers? If you know from so far it's some value of X, some unknown value, since they both have to add up to equal 800, just subtract it out. You just get this crappy quadratic that you have to deal with. All right. Pythagorean theorem still holds true, even though you have what's called a binomial. It's just a matter of putting it together correctly. And I wanted to remind people how that looked. That's how that would look. And just like we did, what was that, last Wednesday, I think, when we had the similar triangles where we had a couple of the binomials we had to square out. Remember, it's not just distributing the exponent. You have to actually multiply 800 minus x times 800 minus x. And like I said, you just get some crummy numbers. One of the things that people were asking about earlier is that am I going to ever give you problems that look this awful with this large of numbers? No, but it's the same process. It's the same process. Never FOIL? Remember that? Yes, no. Okay. Do you remember Billy Binomial? Who showed you Billy Binomial? You're just agreeing for the sake of agreeing, aren't you? Yeah. Anyway, so you would have to FOIL all this out. You just get some large numbers. 800 times 800 is what, 64? Too many zeros? 4 zeros. Few zeros. Yeah, right. All right. From there, you have to set aside equal to 0 and do all the factoring. Don't freak out about the ones that look this awful. I know it's easy to freak out. But all you have to worry about is if I ask you, could you set up Pythagorean before we get to it? We haven't done enough algebra together to make sure you guys remember how to do all that. But you could set it up, right? That's kind of what I'm looking at. What else do you have that was on that sheet that was awful and scary and bad? 31? Last one of these, and then I'm going to show you a couple other notes for today that helps finish out this section. And let's go from there. So in 31, you can do one of two things. You have a rectangle, two triangles, or what's the overall shape? You know what that's called? Trapezoid. You could have looked up the formula for a trapezoid. Either one of them is going to work. But no matter what, you have to figure out how tall this is. What's the height? The distance between the bases. So you have to do a little bit of subtraction here. If you know that the top part is 26, that means as you bring it down here, that has to be 26. You guys agree? Now, if that whole bottom is 62, you back out 26, you have, what's that? And so what do I do with the 36 then? Good. What's half of 36? Good. I'm sorry. Next time I'll have a spotlight. Make it even more. No, you're right. You're right. You're absolutely right. So those, by splitting those things up, because you got those congruency tick marks, which seemed a long time now, all we have to do then is just use Pythagorean theorem once to figure out the overall height. Now, the overall height, is that going to be a hypotenuse or a length for those right triangles? Okay, good. So we just write it up as 18 squared plus something squared is 30 squared. Okay. Have you guys started to write it out like that before pressing all the buttons over and over again? Knowing that you'll have to take whatever that 18 squared is and move it over, you might have to move it over first and do it all at once. It's fine. Or go the longer way, it doesn't matter. You're still doing the same amount of work. So you can type in the calculator, 30 squared, subtract 18 squared. Then take the square root. You guys know how to take the square root of your answer? Have you done that yet? So if you have that and you typed it in, you get 576. And you know that you have to take the square root of it. Just hit the square root of your answer. One of the reasons of being able to do that is because that answer button stands for the last thing you hit enter again. We use the answer button a ton later on. Okay? So if you haven't been using the answer button, try it. Try to see, write down your number, but then hit answer as you're doing the homework and whatnot, the practicing of it. That way, when we actually get to the point where we need to use the answer button, it won't be like, oh, what do I do with it? Because by the time we have to start using the answer button, you're going to be using the answer button from god-awful decimals. You don't want to write down a string of 12 digits. You just want to hit answer for it to be. So back to this. Gives us the 24. So you have two triangles plus a rectangle, or you have a trapezoid. It doesn't matter. It'll work for either one. 2, 1/2 base of 18, height of 24, plus a 26 by 24. type all that in, look at the overall area. Or if you had looked up what the formula for the trapezoid was, it's half the height times, yes sir? 36? This chunk here is 26 because we brought this down because we created the rectangle. And then that's why we have the tick marks, is where the 18s come from. So if you looked up the trapezoid one, once again, these are pretty quick formulas. You had half of 24 is 62 and 26. And those are a bunch of numbers I don't know how to do in my head. Does that help on that? Adios. Bonjour. Oui. See what I did there? All right. So, what is this? What's that? Save it. What am I going to add to it? What's that called? The what? What equation? Pythagorean theorem. What does this only work for? What kind of triangles? So, does it change anything if I write it like this? So, here's what we do. I'm going to write this as an if-then statement. What happens as we get into this this last half of this stuff for today is that we're going to be able to look at values, side lengths of a triangle, and we'll be able to tell whether or not it's a right triangle, obtuse triangle, or an acute triangle. The only thing that's a little bit different is that we're using what's called the converse of the Pythagorean theorem. Remember we did converse, inverse, contrapositive a long time ago? Converse was basically saying stuff backwards. So if a squared plus b squared equals c squared, then we know we had or if it's a right triangle, then a squared plus b squared equals c squared. Well, saying that backwards is if c squared equals a squared plus b squared, then it was a right triangle. That's how a lot of definitions in really all of math go. They work forwards and backwards, which gives you your excuse me, not conditional, biconditional statement. I forgot what it's called. Okay. Gives you that idea of what's called a biconditional statement. It works going both ways. Now, sometimes you get this. This value of c squared could be smaller. This value of c squared could be larger. Now, these are for so for all of these, when we start looking at this in terms of given three values, the largest of the three values will always be playing the role of the c. Okay? So you can get, if the c squared is smaller, or you can have the c squared be larger. Well, this is really easy to figure out. Then it's acute. Then it's obtuse. And the reason why that they put it the c squared first is because if we say that something is small, we think smaller than something. Obtuse, it's larger than something. That's why they write it backwards. Right? That's why we write it backwards. Versus a squared plus b squared is greater than c squared. Most textbooks do it this way. So if you're given sets of values, for example, if I'm given 13, 5, and 12, and I want to classify what kind of a triangle that is by those side lengths. Thank you. So if I want to figure out which one of these it's going to wind up being, which one's playing the role of the longest silent? 13, 5, or 12? 13, right. 5 and 12 doesn't matter. Which one's which? No. So what you're doing is you're checking. Remember when we did stuff like this before, you're checking. What is the relationship of 13 to 5 and 12 when you put it into Pythagorean theorem? And now it's just a matter of pressing buttons. And check to see, is one side larger than the other? One side equal to the other? The sum of the other, excuse me. What's 25 and 144? A big number. That number is? So are these two equal, larger, or smaller? So therefore, what kind of triangle is it? When you're dealing, does the Pythagorean theorem hold true? Yeah. So the Pythagorean theorem held true. What kind of triangle is it? Oh, right triangle. Yeah. So this would be a right triangle. That's what we'll be able to do. Okay. Given sets of sides. For example. I want to look at 14, 50, and 48. I want to look at 14, 15, and 48. 14, 50, excuse me. 14, 50, 48. Which one of those has to be playing the role of the value of C? The big one. Good. That one would be 50. So what you're doing is you're just checking. What is 50 squared? Is that equal, smaller, or greater than 14 squared plus 48 squared? Well, the 50 squared, that's easy. That's 2,500. And then you just put the other two together. Ooh, look at that. Are those equal? Therefore, it is a do you guys know how to check which one works for radicals? Because a lot of times they're going to give you simplified radicals. Whether it's just the square root of 13, or it might say 2 root 3, or 9 root 2. It could be anything like that. And you're not sure what the relationship is to the other numbers that are given to you. So what you have to check to see if it is the largest or the smallest or whatever, what you want to be able to do is you just get what's the decimal equivalent. Thanks, Daddy! Lady. So decimal-wise, what is the square root of 13 equal? Do you know how to check that? Double arrow. Double arrow. So put in the square root of 13. If you hit enter, it'll come out with the square root of 13. Right. What I'm getting at here is you're just trying to see the relationship to, is it bigger than 10 or is it bigger than 12? Okay. That's what you're looking at doing. Again, as you put it together, you're checking the relationship between the 12 12 squared is how much? 12 squared is what? I was going to say, like, wait. Want to ask Siri on that one again? I don't know at this time. And then you get 100 plus 13 would be, what's the relationship? It's greater, which makes it what kind of a triangle? That's all it is. Super easy stuff today. Super easy stuff. Pretty much. I've got problems that look like this, and I've got some more problems of right triangles where you're solving for either the hypotenuse or a leg. Okay? Not too bad. What we're going to do, well, all right, let me take that back. What we're going to do tomorrow is we're going to work on what are called triples. Triples are families of numbers that no matter what you do to them, if you multiply any of them by the same value, it will always create another right triangle. For example, what's 3 squared? What's 4 squared? What's 9 plus 16? Doesn't that equal 5 squared? The answer is yes. If I double all of these, you get that. What's 6 squared? What's 8 squared? 64 plus 36 is how much? Not 12. It's 100, which happens to be 10 squared. Phone in a friend? So what happens here is that we're going to look at these. It's not that you won't get your calculator lying around, but I tell you one thing, when you get to some upper level stuff, knowing some quick patterns of triples, it just makes everything so much better. We'll talk about that tomorrow. Tonight I have stuff out of the book. So this is in the textbook. If you did the worksheet on a separate sheet, just add to it. We'll staple this with this stuff together tomorrow. We'll go through those. I want to make sure you saw this tomorrow. Do you